questions? Do you have any questions on 10A? You should have questions. But if you don't, you ask another time, that's okay. Good morning. Let's see who's there. Good morning. Tiffany. Good morning, Tiffany. All right. Do you have any questions on 10A? If you don't, or don't for now, I wish to cover this section with quadratic one. With a quadratic one. Okay, we're gonna start with the quadratic one, but at first we're gonna talk about what is a quadratic. Obviously, x plus 2 times x minus 3 is a quadratic, right? We solve this inequality, but we also see this as a function. And this function actually is a quadratic function. Okay, this is a quadratic function. Okay. Regarding quadratic functions, we actually have, you guys definitely have seen it, but I make it as a category of function to talk about. It's because it's a very important category of function. Okay, there are a lot of ideas handling quadratic function is also used to handle other functions as well. Okay, which we have seen some of those. I've seen some of those. Okay, so but anyway, rather than talking about this abstractly, I want to start with the simplest quadratic function. Okay, the simplest quadratic function. The simplest quadratic function. Simplest quadratic function. Okay, the simplest quadratic function actually was a function we have seen in basic 1, x squared. Do you guys remember this function? Do we remember this function? Yeah, x squared, right? We talk about this function's domain and range. Just, you know, we cover that. You guys have seen that before, okay? And this is the simplest form of quadratic function. And there's a general form of quadratic function. Okay, the general form of quadratic function is f of x. Okay, we use the same name, but we probably should use it, you know. But as long as each function is defined properly, okay, so ax squared plus bx plus c, provided a is not 0. How are these two related? One looks so simple and the other one looks a little bit more complicated, right? Actually, it looks much more complicated. And we call it, this is a general form of quadratic function. Okay, and what are ABCs here? Okay, in the general form of quadratic function, right? In this general form of quadratic function, what are ABC? What are those? Okay, we know that x is called input, f of x is input, it is output, and sometimes we even should introduce a y, right? And in these forms, right? In these forms, x is the input, y is output, f of x is output, ax squared plus bx plus c is output, right? So x is the input, so x is the input, y is output. or f of x is output. But what are ABCs? ABCs are called, they're called parameters. Okay, parameters. In comparison, x is called a variable. Y is called a variable. Do you guys follow me? What's the difference? What's the difference? Okay, so parameters are A, B, C. Okay, when we assign different values for A, B, C, and we will get a different quadratic function. For example, okay, I want to show you the rows of parameters. Okay, the row of parameters. Okay, because to many of us, these are just symbols, right? They're just all symbols. Why ABC? Why XY? Why they're called different names? Why they're called different names? Okay. For example, if I let A equals to 1, B equals to 0, C equals to 0, what will happen to this general form? If I substitute A by 1, B by 0, C by 0, by 1, by 0, by 0, what do I get?
X squared.
I get x squared. Okay, so this is the case that when parameters are given, we have three parameters. Parameters are assigned values, and the function is decided, right? The function is decided. And this is the difference between parameter and variables. Okay, we still have our input and we still have our output. Okay, it's just the rule is more specific. The rule is more specific, but we still have the x squares, right? We still have the x squares, and the highest degree is still x squared, right? The highest degree is 2. Therefore, you can see the difference. Give you another example. Okay, this time I'm going to assign A equals to 1, A equals to 2, B equals to 0, C equals to 0. What will be the consequence after that assignment? A will be 2, B is 0, C is 0.
2x squared.
2x squared. You can also see that these are the individual cases of quadratic function. Does that make sense? We're given a set of parameter values and we get individual cases. Okay, it's more like everybody, we're all called human, right? But this person, that person, we have our own characteristics, and those characteristics, maybe are ABCs. Does that make sense? All right. So by giving us the specific values of for the parameters, we get individual cases of the quadratic function. And oftentimes we are dealing with these quadratic functions. So oftentimes what we deal with is actually these functions. Okay, so let me give you a few more cases. Okay, and you can see the making of quadratic function, okay, in individual cases. The next example I'd like to give you, I'm going to give you A equals to half, right? A, B, C can be any real number, and B is 0, C is 0. And as a consequence, what will be that quadratic function? Well, this is half. And over here is gonna be, they're gonna be gone. And we're left with a half of x squared. And we can keep this list going, okay? I can assign a equals to 1, b equals 0, c equals to 1. And what will be that consequential quadratic function in that individual case? So what will be that individual case? A is 1, b is 0, c is 1. Okay, 0. So what do we end up with?
X squared plus 1.
Yep, very good. Plus 1. Another case. So I'm going to give you a few more cases and you guys are going to work out the quadratic function. Okay, so we see how parameter, can be assigned values. Okay, so a equals 1, b equals 0, c equals to -1. Okay, so give me that quadratic function. And more, I'm going to have a equals to 1, b equals to 2, c equals to 1. Another one. Okay, last one for now. -2. So can you spell out the consequential quadratic functions? And all of these are different rules. All of these are different rules, right? So one is 1, and this is 2, and this is 1, and this is 1. Oh, wait. This is, this is 1, and this is 0. My bad. -1, and this is 2, and this is 1. This is 1, this is a -2, and that's a 1. Right? Okay, so let's simplify them. And this one will turn out to be what? X squared -1. And what would this be?
X squared plus 2x plus 1.
X squared plus 2x plus 1. And the next one, x squared minus 2x plus 1. Okay. Now the question is, if we call this kind of function a class of function, okay, because a quadratic function is a class of function. It includes all of these special cases. We can see these are all special cases of quadratic functions. What do this class have in common? That's what we want to study. We want to study this class of quadratic function. What do they have in common? So by studying the individual cases, maybe we can figure out the whole class and what they have in common. Okay, so that's the strategy we're doing here. So these are the functions that we're going to study next. Okay, these are the functions we're going to study next. Okay, so we certainly know we certainly know x squared, don't we? We have did we graph x squared? I think we did. We graphed x squared. We graphed x squared. Did you guys still remember how we graphed x squared? How we graphed x squared? Okay. How we graphed x squared? Plotting points, right? Input, output. This is the input is x, output is x squared. So any input, you just multiply itself and you produce the output. And the consequence we get, okay, so we're going to observe the patterns, right? We're going to observe what do we see in x squared. And then we're going to observe what we see in 2x squared. And what do we see in half x squared. And what do we see in x squared plus 1, x squared minus 1, x squared plus 2x minus plus 1, x squared minus 2x plus 1, right? So we're gonna observe these simple cases. You have to acknowledge these are pretty simple cases, right? Because we assume those ABCs with pretty simple numbers. Could I assume A is 1.5, B is 7.9, C is 100.6? Could I do that? Of course, and I'll be making another quadratic function. So the ugly looking, I will say the ugly looking quadratic function, even that function, what does it have? Does it have that character of all of them? Does it? And the answer is yes, right? So you can see by observing the special cases, we will gradually get the common feature of all of these quadratic functions. So now, I wish you guys to get the graph, or you guys graph this, okay? Input, output. Okay, so this time I'm going to use a table. So graph with me. Input, output. You know what? I forgot to make it. Did I make another function? I should make one more function. Okay, this function is very important. I want to make A is -1, B is 0, C is 0. Would you make that function for me? Would you guys make that function for me? So this is a -1, and this is 0, and this is 0. So in the end, what do we get? We get a negative x squared. Okay. Follow me? So I was just making one more functions that we are about to graph them. Does everybody see this? So please insert this one in your, in the making of quadratic functions. Got it? Now we're graphing x squared one more time. The input I'm going to give you we've done this before, right? So what are the outputs? Everybody plug in the numbers. Input. And the making of the points. Still the same old way. You see, is this way of making points any different from the way we made points when we were dealing trig functions, or we're dealing with any function so far? No difference, right? Do you see that consistency? Absolutely, absolutely. What is the difference? The only difference is the rules are different, right? The rules of making those points are different. And as a consequence, because the rules are different, we say the functions are different, then we get different graphs, and we have different domains, and we have different range, right? So the rule is the most important part for us to understand. The rule decided, okay, by setting up the rule, we will have domain set up, range set up, and the picture setup, So now let's make these points. The input is -2, the output is 4, right? If the input is -1, the output is 1, right? So this is a 4, this is 1, and this is 0, of course, and that's 1, that's 4. Okay, and over here, that's going to be 0, 0, 1, 1. You should commit yourself to do this during your academic years. I promise you, the chance you're going to do it very small after you get your degrees. But doing it is absolutely necessary for your, understanding and learning. Okay, you only have to do it how many times? A couple times, right? A couple times, and then you get it. You understand it. You get it. You're ready to go. This class of function has a variety, has a wide range of applications. Okay, I will point them out after we're done with this section. Okay, as we move forward. Okay, and next we're gonna plot the points. Okay, we are gonna plot the points. So could you please plot the points with me? Okay, so please plot those points with me. Get the dots. Okay, I'm making some adjustment. Maybe this is make it a -3, +3. There you go. And that's my adjusted. And what do we do next? Connect the dots, right? Connect the dots. So let's connect the dots. So please connect the dots. So now, observing this picture, what are the features we have seen? Observing the picture, what do we observe? What have we seen? What are the special features?
The domain and the range.
We can tell the domain and range, right? So let me make it a little bit smaller size. We look at the table and we observe the feature. So now I'm going to make a table so we can put on the, the features that we observed. Okay. What do we have observed? Observation.
It's not one-to-one.
It's not one-to-one. Very good. Excellent. Okay. It's not one-to-one. Oh, sorry. Not one-to-one. I'm glad you have that in your mind. Okay. The domain. What is a domain? What's the domain?
All real
Negative
numbers.
infinity to positive infinity.
Negative infinity to positive infinity. Very good. What else?
Then the range would be a bracket 0 and then parentheses infinity.
Very good. Range, bracket, parentheses, okay, 0 to positive infinity. And what does that mean? Meaning x squared is always greater than or equal to 0 for any real numbers. Right? We'll cover that. What else? What about the curve? There seems to be some kind of symmetry, right? The curve is symmetrical. The curve is symmetrical along which line? There's symmetry.
The y.
The line, yes, it's a symmetrical. Okay, symmetrical with respect to y-axis. Okay. And what is the equation of y-axis? X equals 0, right? The equation for y-axis is x equals 0. Do you guys follow me? Any explanation? Do you need an explanation for it? No, okay. So and we call this, okay, we call this, there's a line of symmetry. This is called a line of symmetry. Okay, line of symmetry is x equals 0. What else? What else have we observed from this picture? Does it have a lowest point? Does it have a highest point? It has a lowest point. And what is that lowest point? 0, 0. Right? It has a lowest point. What does that mean? What is the meaning? When input is 0, the output reaches its minimum value. Okay? When input x is 0, output reaches minimum, reaches a minimum value. And that a minimum value, and what is that minimum value?
0.
That's right. In this case, the minimum value is 0. What else can we observe from this picture? What else can we observe from this picture? And by the way, the lowest point, we're gonna give it a new name. It's called a vertex. And because, okay, there's a lot of other features, okay, there are a lot of other features. For example, if we elaborate on the range, what do we find? All of the input that is not 0, the output are going to be positive. When the input is 0, the output will be 0. So this piece, okay, this piece is a positive. This piece is a positive. That piece is a positive. Output are positive. Do you guys follow me? Remember we're drawing similar things like yesterday? And there's a lowest point. The lowest point right there. Okay, lowest point right there. So we have observed these features, haven't we? Did we miss anything? Did we miss anything?
Is it an even function?
I'm sorry?
Is it an even function?
That's right. It is also an even function. It is also an even function. Okay. I'm going to put it here. Okay. It is an even function. Absolutely. It is an even function. And what else? What else? There are a few other aspects I like to go over with you. Is that when we plug in the numbers, so what is the geometric meaning by plugging the numbers? For example, right? When I plug in f of -1, what I'm doing? Geometrically, when I plug in x equals to -1, I am actually drawing a vertical line. Wait, okay. I am drawing a vertical line. Oh, -1, 10. Don't worry about these syntax, okay? It just, when I cut, okay, you see the broken line I drew there? When I use a broken line, which is x equals to -1, okay, hold on, I'm going to just write it out here, okay? F of -1, that -1 is, okay, this input equals to -1. Okay, this tells us the input is -1. This line is the vertical line we drew here. Do you follow me? And this vertical line cutting the curve, and there's a crossing. There's a crossing. Do you guys see that crossing? And we know the consequence is 1, right? So this point is the consequence of the action of drawing a vertical line, cutting the curve. And as a result, this point is -1, 1. Do you follow me? And all the points that we got from here in this table are being done that way, have the same meaning. So that's the vertical cutting. Okay, that's the vertical cutting. So we can cut every cutting. Every cutting means a plugging in, okay, for that input. Okay, then you say, well, if we can cut vertically, can we cut horizontally? Can we cut horizontally? Absolutely, we can cut horizontally. For example, I can cut horizontally, okay? Suppose I'm cutting horizontally here. Okay, I'm gonna use red. I'm cutting horizontally. What I'm doing here, hold on. Yeah, that's right. And the previous one, I'm gonna make it a green. Just make a little distinction, okay? The vertical cutting, I'm using green. The horizontal cutting, I'm using red. And the horizontal line I cut with it, And what is the geometric meaning, right? You see, when we cut vertically, it's plugging a number, plugging the input. Horizontal. Cutting the curve. Okay, which is this red line. This is the geometric meaning. What is the algebraic meaning? The algebraic meaning will be the output equals to 2. This line, the red line I drew here, is y equals to 2. The input is 2. I'm sorry, the output is 2. Okay, so in this case, let me try to make this very clear to you, okay? So that there are only 2 kinds of cuttings in general. Of course, you can cut it, diagonally. This kind of cutting is a vertical cutting. Okay, basically you give input a -1 to the function, and you have the function f of x equals to, you're gonna get an output. You're gonna get an output. That's gonna be -1 squared, right? Give same function. And geometrically, that's a vertical cutting. Horizontal cutting, however, is you're given the output. You're given the output. Input is not known. Okay, the function is still the same rule. And the output, okay, so let me clean this up. The output is 2. You follow me? So we want the output is 2. The output is 2, and we're looking for input. This is the typical if statement. Okay, usually they will say if the output is 2, give me the input. Okay, that's a kind of scenario. So when you guys look at these notation, right? F of -1, f of x equals 2, these actually send us different messages. This one tells us the input is given, which is a vertical cut. And this one is telling us the output is given. We're looking for input, so it's a horizontal cut. Did I make myself clear? Everybody? Then you will say, is this the case for any function? And I will have to tell you the yes. Okay, so we're not only studying quadratic function. Yes, we're studying quadratic function here, but what we study here is going to be applicable to all of the other functions. Not every feature, of course, not all the functions have the symmetry feature, but a lot of other interesting phenomena, they actually are similar, like a vertical cut, horizontal cut, they are all similar in that nature, okay? All right, without further ado, okay, we have observed these features. And next, okay, next, we want to do 2 times x squared. Okay, so you guys is going to follow me. Let's do 2 times x squared. 2 times x squared. That was oh, wait. Okay, let's do that. That's not changing. 2 times x squared. Let's do 2 times x squared. Okay, so once again, I'm gonna make a table, and you guys will help me to complete the table. And the rule is different now. Okay, so it's 2 times. Everything's 2 times. So for 2x squared, could you guys plot the points? Are you calculating? Okay. I'm going to put this away just temporarily. Okay, you guys do the calculation. Are you done? You done? Not yet? Okay, take your time. All right, ready? We're back. 2x squared. So what I'm going to do is I'm going to put this one right next to it. Okay, I have marked those points in the x squared, right? This is x squared. Now we get a new points, right? We got new points. And this one is 8. Is that 2? 0. And this is going to be 2, right? This is going to be 8. Do you guys follow me? We get the same points. So what we're going to do next is that we're going to put the new points in the same picture. Okay, so -2, 8. -1, 2. 0, 0. 1, 2. 2, 8. So can you put all of these points on the same picture? Okay, I'm doing that with you. If you have a colored, colored paper, pencil, pen that you can tell that, can show you some differences, feel free to use that. Okay, I'm going to use, let's see what color I'm going to use. There's a chat message. Hold on, let me check that chat message. Ah, someone says horizontal stretch. Horizontal stretch. Okay, we put that there. Okay, we leave that question there. And could you specify what is horizontal stretch?
By horizontal stretch, I mean when the curve stretches out like to a wider degree, sort of sense, like the curve is wider.
The
From
curve
left
is
to-
wider. You think the curve is going to be wider, yeah?
Yes.
Okay, we'll verify that. We'll see if that's correct. Okay, so can you guys plot the points in the same picture? I'm going to do that as well. Okay, I'm going to use green for the points. Everybody, please do that. I'm telling you, this is the simplest thing for us to do to gain some insight. Okay, if you don't do this, you forever have to memorize, and then you get confused by your memorization, which happened to me as well. It happened, I would imagine it probably happens to everyone, I imagine. Because I'm this, I have to learn everything by the hard way. I learn everything by the hard way. So I may not be right by making that kind of statement, but a majority of the population, we're not genius, right? We're not a mathematical genius. So we have to do it and see it. Okay. So 2 more points. 2 more points. 1, 2. 2, 8. So I got my dots. I've got my green dots. Did you get them like that? Yeah. So what kind of stretch is that?
Would it be vertical?
Let's not talking about those other terminology. Comparing to the previous curve, is it wider or narrower?
It's narrow.
It's narrower, isn't it? So if we connect the green dots, when you have that visual image in your head, right? Does it really matter how you call it? No. So 2 times x squared is what happens. It's more narrow. And does it still have the same feature as what we covered, right? These features, these observation we made. Let's check the list, right? Can we check, can we make a check? Can we check the list? Let me see where I'm gonna put it. Okay, the checklist, right? We got a checklist and we got this curve, right? So I'm gonna take these picture. I'm gonna put it next to me. Is it still not a 1-to-1, right? So let's check this list. Shall we? It's still not a 1-to-1. Is it still an even function? Is the domain still negative infinity to positive infinity? How about the range? Range is still the same, right? It's still, you know, at 0 or above 0. Is it still symmetrical? And the line of symmetry, the range, this time the range, you have to put a little, if x squared is greater than equal to 0, of course, 2 times x squared is going to be greater than equal to 0 as well, right? So now let's continue on this list. Does it have the lowest point? Yes, it does. And what is the lowest point? Still the same, yeah? How about, well, the meaning is the same. The output, when input is 0, the output reaches a minimum, which is 0. Everything the same, everything the same. And guess what we're gonna do next? We're gonna do half x squared. We're gonna do half x squared, okay? Cortland, I appreciate your contribution of horizontal stretch, but if you can find out for us, what is the definition of horizontal stretch? And I think the rest of the class would like to have a clarification, okay? Thank you. Okay, I want to not only just Cortland, everybody find out, okay? Go check some reference books, you know, whatever. What is the horizontal stretch? Okay, so we have checked the list, and next we're gonna do half x squared. Okay, so the next function we're gonna do is half x squared. Okay, so maybe I should give a different name. G of x equals to half of x squared. In these two tables, right? Before we do the half x squared, in these two tables, I give you the same input, and what happened to the output? The output is doubled. The output is doubled. That's why it becomes narrower, more narrow. How should we say that word? Narrower or more narrow? And this time I can make the excuse that English is not my first language. It's not my mother tongue. So I have an excuse not to know that grammar. Is it narrower or more narrow? Come on, guys. You need to help me out.
I guess
Huh?
it'd be more narrow. I guess
It's
it'd be
more narrow. I found that easier to pronounce. Okay. Narrower is a little hard for me. Okay, it's more narrow. Okay, what's thinner? Right? And what will happen if we work on half x squared? I think you guys start to visualize already, do you? You see, once you start to put on your paper pencil, you start to visualize, you see much more than what you just write it down. So next, when we're gonna make the table, okay, we're making the table, okay, so now we have 3 tables, okay? 1 table, 2 tables, 3 tables. Okay, I'm removing the picture. I'm adding another table. And this table, I'm going to put it here. You know what? I'm going to put it in the middle because that's it, make it easier to see. Okay, but this time the rule is half x squared. So everything, all the output will be halved. Do you follow me? All the output will be halved. All the output will be halved. And there's a consequence. There's a consequence. I did not change the input. So this is going to be 2. And this is going to be half, isn't it? And that's still 0. And that is still half. That is half. And this is going to be 2. So what do we see? In one case, the output is doubled for the same input. In the second case, the input say that for the same input, the output is halved. Does that give us some sense about the picture? Does that give us some sense about the picture? Huh? Does it?
Yeah.
And we need that. We need that sense. We need that sense. That sense give us intuition. That sense give us intuition. Our intuition is built on it. Your mathematical intuition is built on it. Not by memorization. Memorization cannot be trusted. So now we plot the points. Okay, now we plot the points. Okay, I'm going to start to plot the points. Okay, you plot yours, I plot mine. I'm going to choose a color. I'm going to choose this color. Dot. Okay, -1, half. Zero, zero, still there. 1, half. One more. 2, 2. All the dots there. You got all the dots there. Shall we connect the dots? Shall we connect the dots? Now, we're going to mark each picture because we really want to understand. And we also going to go through the checklist. Okay, we're also going to go through the checklist. Okay, we will go through the checklist. So can you guys mark this picture? This is x squared, isn't it? Right? And the green, what is the green?
2x squared.
2 times x squared. What is the blue?
half times x squared.
Half x squared. Okay, for any input. So for example, for input equals to 1, right? If you look at the table, I want you guys to look at the table you just did. For that particular input, right? For that particular input, on 2x squared, right? On 2x squared, you can see that the 2x squared is doubled in height than the x squared, right? And half x squared is halved. Okay, so let me put this, let me do it this way, okay? Let me do it this way, okay? So this is the x squared. Okay, I want to see if you guys have some visual, okay? This is x squared, right? The black is the okay. What is the green? This is how high the green, right? The green is doubling the black. Yes, do you guys see that? That's 2x squared, right? That's 2x squared. That's the green. How about the blue? The blue is a half of x squared. Do we get some senses now? So that's why one picture is thinner, the other one is wider. That's how it's, one is thinner, one is wider. Do you think you guys can go through the same process for yourself all over again? Yeah, is it that hard? Do you have to rely on memorization? Do you think you have to rely on memorization? No, not at all. In fact, all the functions in terms of shifting, transformation, you know, they can all be handled the same way. That's the point I want to make. All of them can be handled the same way. You don't need a memorization. To tell you the truth, a lot of people study mathematics because they don't want to memorize in psychology or biology. You don't need to memorize. Okay? Double, half. Okay. We're done with that. Shall we go through the checklist? Let's do that. Let's go through the checklist. Okay, where's the checklist? Where's my checklist? Okay, here. Right, I got my checklist. I'm gonna put it right here. I'm sorry, this picture, the software doesn't line up with me, or I haven't figured out how to line them up, okay? So okay, let's go through the checklist. Okay, it's still not 1-to-1, right? Is it an even function? Yes. How about the domain? Same. Range? Yes. All right. And over here, if you multiply half x, it's still greater than or equal to 0. No problem. So that is still true. Is it symmetrical? Yes. The line of symmetry is still the same, right? How about does it have the lowest point? Yes, we have the vertex. The meaning is still the same. We have the lowest point. Wow, we have discovered there's a lot of commonalities among these three functions, right? And next, of course, we're going to take a break, but I want you to think about something during the break, okay? The next one, we're going to do negative x squared. Oops, we're going to do negative x squared. Okay, at that point, okay, when you come back, we're going to take care of this function. Okay, I'm kind of using this name all over again so many times. Okay, equals to negative x squared. Okay, for which we're going to plot points. Okay, still compare with our x squared. And we're going to make another, I'm going to use a new rule. There's a negative sign in front of it. Okay, so now we're going to leave at this point. During your break, I want you to think about getting the output and making the points and plotting the points. Okay, so let's take a break. We'll come back in 10 minutes. How about that? I'll see you soon. All right. Welcome back. Okay. You know, during the break, I was looking up on this pre-calculus textbook about vertical stretching, horizontal stretching, which I'm going to talk about after this. Okay. And you know, those wording, you really have to look at those details. Okay, you really have to look at the details, what it really means. Okay, so I'm going to address that after we're done with negative x squared. So did you guys calculate? So this will be -4, right? Anybody have issues evaluating this guy? Okay, so I need to give you a little detail, so just in case, okay? If you look at negative of -2 squared, it really means negative, the negative sign, and -2 times -2. This is very different from this, okay? -2 squared is -2 times 2, okay? -2 times 2, you follow me? It's also equals to -4. The important part here is that if you look at this part, okay, it's an exponential form. The base is -2, the exponent is 2. And you look at this part, the base is 2, the exponent is 2 as well, okay? And also there's a difference between -2 squared and -2 squared. I know it's hard to tell the difference when you read it, you know, without writing it down, isn't it? It's very difficult to tell the difference. So everybody look at these two. Are they the same? They are absolutely not the same. Okay. The former means that. The latter means this. Okay. The second one doesn't have a parentheses around -2. Therefore, the base is 2. The first one, however, there's a parentheses around -2. So the base is a -2. Do you follow me? And the result is very different. So I'm taking this opportunity to clarify these, minute detail. Okay, so over here is going to be -1. And of course, that's still 0. And that's going to be -1 and -4. Okay, so here's -4, -1, 0, -1, -4. What do you observe in terms of output? We still use the same input. What happened to the output? The output, instead of all positive or 0, they turn into what? All negative or 0. Do you guys see that? Okay, if you think of the checklist, something is not going to be true anymore, right? Something is not going to be true anymore. Now, we're going to plot these points in the same picture. Would you plot these points in the same picture? Let's not do that. Okay. Is that what you got? Maybe we can go a little faster this time, right? So let's go down the checklist. Let's go down the checklist. It's still not a 1-to-1, that's true. Even function, domain, range. Range the same anymore.
No, it would be negative infinity.
That's right. So the range need to be changed. Okay, the range need to be written this way. Negative infinity, comma 0. How about this side? It's going to be negative x squared less than or equal to 0 for any real numbers, right? You can see that? So domain and range are not always the same, right? So can we take that range out of, we're going to put this a question mark. Okay, they're not always the same on the checklist. Yeah? So we can say range. What about range? Varies. Range varies. Okay. How about line of symmetry? Line of symmetry. Still the same. Okay. How about vertex? Still the same. Lowest point or highest point? Lowest point or highest point? Do we have a lowest point, or do we still have a higher? Do we still have a lowest point? Well, we don't have the lowest point. We have a highest point instead this time. See, we don't have a lowest point now. We have a highest point. Okay, so this will be what? Highest. Have a highest point instead of lowest point. Oh. Sorry about that. You know, there's too many pictures. Sometimes it just, so this is no longer the common feature. Okay. But the vertex is still the same. So, but this piece also varies, right? The vertex varies. In terms of lowest point or highest point, that varies. How about the minimum maximum? We no longer have a minimum. We actually have a maximum. Maximum. Do you follow me? So now let's do a brief summary. Let's do a brief summary. Okay. All of these features, all of these curves we have graphed so far, right? They have some common feature, but some feature varies in terms of domain and range. They seem to be domain are all the same, yeah, so far. And range varies. Lowest point or highest point could vary. Yes. Now, I want each one of you take your paper, pencil, and you're gonna mark these pictures by yourself. One more time. Okay, so I'm gonna try to use a color coordinated. Okay, so this is x squared. And the green. Okay, 2 times x squared. Half x squared. Last but not least, negative x squared. So how about in terms of opening? In terms of opening, remember we talk about the general form, right? We talk about the general form. A times x squared plus bx plus c. It seems that all of these that opens up, they have something in common, isn't it? Right, all of these opens up. When A is a positive, opens up. Okay, sometimes we say concave up. Concave up. For A is less than 0, which is a negative x squared case, opens down. Or we can say it's a concave down. You see, these are the A's, right? These are the A's. So what are the A's? This is the A. A is 2. A is 1. A is half. A is -1. When A is positive, doesn't matter, is a fraction, decimal, whole number, is going to open up. When A is negative, -1 is going to open down. So can you imagine negative 2x squared? Where would it be? Can you imagine negative half x squared? Do you know what I'm talking about? Where would it be? They will flip over, right? Will they flip over?
Yeah.
You follow me?
Uh-huh.
That's right. So, but we're not going to do it, but now you can imagine that, right?
Yes.
Okay, very good. So now we've done all of these. Okay. And next, we're going to do another set. We're going to do two more. We're going to do actually 4 more picture. Okay, we're going to do 4 more pictures. And did you write it down? Did everybody write it down? So we find some common features, right? And there are some variations, and some of those may or may not be true as we progress, right? And next, the next 2 pictures I wish you guys to graph are these. Okay, we done them earlier. One is x squared plus 1, and the other one is x squared minus 1. With the experience we had earlier, okay, with the table, I think you guys can do this very quickly. Okay, so we're gonna have a table doing x squared plus 1, and we're gonna have a table doing x squared minus 1. So the rule has changed. And it causes consequences in the output, right? It has a consequence in the output. So I want you guys to, for the same input, I want you guys to give me the output. And then you start plotting points. Where do you plot points? Okay, I want to make it a little simpler for you. Okay, so for it's easy, make it easier to plot it just with x squared. Okay, just plot it with x squared. Okay, I'm gonna remove the green and remove the red. Okay, just plot it in this picture. All right. Did you get that picture? Okay, so let's see what's going on. Compare with that table we just worked. X squared, right? You see, I did not change the input at all. The input all stay the same. Okay, but for the same input, what happened to the output? On this one, x squared plus 1, the output is added by 1 for each one of them. Each output is added by 1. You follow me? Each output from x squared is added by 1. I'm sorry, this is 5. Okay, my bad, 5. Okay, and this other one is subtracted by 1. Do you guys see that every output is subtracted by 1 from x squared? And what will be the consequence? Right here. Okay, now let's mark these 3 pictures. Let's mark these 3 pictures. The black is x squared, isn't it? Oh, sorry. So awkward. Can't write well with the mouse. Okay, x squared, right? What is the green? What is the green?
X squared plus 1.
That's right, x squared plus 1. What's the red?
X squared minus 1.
X squared minus 1. If you draw a horizontal line arbitrarily, suppose I draw this horizontal line arbitrarily. Okay. This is the point. This point is at, this point is on the x squared. Okay. And another point is on the green. Right? And one more point is on the red. What is the vertical distance between these 3 points? They are 1 unit. They're 1 unit. That's the adding 1, subtracting 1. Do you follow me? That's the adding 1, subtracting 1. So this kind of transformation is called shifting vertically, vertical shift. The entire picture is shifted up or shifted down. No horizontal movement, just the vertical shifting. Do you follow me? I hope that is clear. Okay, so the distance, okay, this is the plus 1. I should use the green, sorry, I should use the green, okay. This is 1 unit shifting up, that's x squared plus 1. And this is the 1 unit as shifting down by 1 unit. So that's a green, up by 1, subtract by 1. Okay, so after the square, okay, be careful. After the square, we adding 1 or subtracting 1. Adding 1 shift up, minus 1 shifting down. Do you think you start to have some senses now? It's easy, right? Is it easy? Okay. One more set, okay? But this time I will have to give you the input, okay? And you can think about why I gave you those input. That's okay, I will explain it to you. Did you guys write it down? Did you guys write down everything? Okay. The next one, what do? Okay, we're gonna do 3 tables as well. But these 3 tables is slightly different. Instead of x squared plus 1, we have x plus 1 squared. Okay, so the rule has changed. You have to do it all over again. And all these input will be, oops. Never mind. I'm gonna make it right, okay? So I'm gonna insert some rows. I'm gonna insert 1, 2, 3, 4, 5. I'm gonna insert 5 rows. Okay, I will give you new input. But just, I want you guys to look at the rule. The rule is gonna be x minus 1 squared. So the square is after the sum or differences. Okay, so all of these will be changed. Okay, are you ready? I'm going to give you inputs. Okay, I'm going to give you input -1, -2, -3, 0, 1. This input, I'm going to give you 1, 0, -1, 2, 3. You know what to do, right? You know what to do. You just plug in the numbers. We forgot to do the checklist for the previous one, but a lot of things we're going to do it together. Okay, we're going to do it together. So while you guys doing the calculation, I'm going to bring down the checklist. I'm going to put the checklist right here. plotting those points, plotting those points. All right, guys. I think we have to hurry up a little bit if we want to. If we want to have a closure on this part. I trust that you have plotted the points, right? You have plotted the points. Did you get these pictures? This is still x squared. Oh, too thick. Okay. This is x squared. What is the green?
X squared plus 1.
X plus 1. That's it. There's a square, right? How about this one?
X minus 1 squared.
X minus 1 squared. Very good. You can see all the points I marked on the black. Okay, on the x squared, they're being shifted left or right according to the rule, according to the new rule. Is that pretty clear, everybody? Okay, so that's a shifting left and shifting right. And we haven't done the checklist, right? We have not done the checklist. Let's quickly do the checklist for this guy. Okay, we haven't done this checklist. Maybe we just do this checklist first, okay? And then we go back there. The checklist. not one-to-one still is true. How about even function? Look at the green and look at the red. Are they still even function? Not anymore. You follow me? They're no longer even function because even function has to be symmetrical with respect to the y-axis, right? The green is not, and the red is not. So finally, for the first time, you can see the even function is iffy, right? It's iffy. So that should be taken away from the common feature because not all of them have the same feature, right? So this one will have to be taken away. Okay, right now I'm just crossing it, okay? Now, domain, still the same. How about range? Range certainly varies, right? In this case, okay, the range, I'm sorry, I need to remove that, okay? The range in this cases, right, is still, it becomes 0 to positive infinity again. Because x plus 1 minus 1 squared is going to be greater than equal to 0 as well. So you can see that the range varies, right? Vary, and there will be more variations as we observe. How about the line of symmetry? Line of symmetry, is it still symmetrical with respect to y-axis? Not anymore. So this become varies, isn't it? So this feature varies, but does it have a line of symmetry?
Yeah, they're just not the same.
That's right, they're just being shifted, right? So for the green, what is the line of symmetry?
X equals to -1.
Very good. So the green, the line of symmetry is x equals to -1. How about the red?
X equal to 1.
X equals to 1. Perfect answer. Excellent. Okay, I want you guys to write it down. If you don't understand, you have questions, and come back to me. Okay. So the line of symmetry, obviously, what? Varies. Okay, so let me write it down here. Varies. It's not always the same. They're not always the same. So the line of symmetry varies. Okay, not always the same. Not always the same. Now, vertex. Is the vertex still the highest point or lowest point? And what is it? Obviously, the lowest point has been shifted, right? So as we said earlier, the lowest point has shifted. So this piece is varies. So vertex varies. And as a result, the maximum could change. Okay. And all of these are questionable. All these places are questionable. Yes. Now, last but not least, okay, we didn't do the checklist for the earlier one. We forgot to do that for this one. Okay. For this one, what is the checklist? Right? It is still not 1-to-1. That's correct. Is it still even? Yes, still even. Domain and range varies again, right? The range varies again. In fact, the range here is going to be, vary. So what are the range? For the green is at least 1. Okay, the range varies. Okay, so I'm going to write it down here. Okay, so x squared plus 1 is going to be at least 1. Okay, how about x squared minus 1? X squared minus 1 is going to be at least -1. That's the red. Do you guys follow me? So you can see the range could vary too. The range varies too. How about line of symmetry?
The same.
Line symmetry is the same, and these two are the same. How about the highest point, the lowest point?
Those ones are different.
That varies, right? This is the highest point. This is the lowest point. And we don't have the highest point here. We have a lowest point. The lowest point shifted because everything was shifted up or shifted down. So in this case, the point varies. Okay, varies, sorry. Okay, so we have 5 minutes. We're gonna summarize. So far. Okay, so far. About from these examples of quadratic functions, okay, which we can summarize all here with all of these pictures. Okay, just move that away. Hold on. As a summary, for all of these functions, right? These are all the pictures we've done today. They're not a one-to-one. Okay, that still hasn't been, there's no exception. Even function, it's not going to be a common feature. Okay, it's not going to be the common feature. Domain, yes. Range varies. Range varies, right? Line of symmetry. Line of symmetry with respect to something, this is going to be questionable. The line of symmetry exists, but varies. Okay, so symmetrical, yes, we still have symmetry, but with respect to what? That varies. Right? Varies. And so the line of symmetry varies. Now, highest point or lowest point varies. So vertex varies. Max or min, okay? Max or min varies. Okay, did we leave anything out? Common feature, right? We observe from these cases, we get these common features. Okay, so now, what next? Okay, we're going to study more general quadratic functions, which is going to be starting from next week. Okay, meanwhile, you guys still working on basic 10A. Okay, so continue to work on basic 10A. Okay, 10A. Review today's lecture. Really do it again. Okay, I forgot I haven't talked about these horizontal stretch. Okay, the horizontal stretch we have here today is the first 3 pictures. Okay, hold on. Let me remove that. These three, okay, over here, these are horizontal stretch. I'm sorry, vertical stretch, or shrinking. Okay, according to the pre-calculus textbook. I personally often get confused by these wording. To me, the best tool is get to the points, get to the detail. Okay, so I have the book with me right here, okay? When I have any confusion or sometimes, I forget things and I get a little, blurry about certain things, I just look it up, study. But the most important part is really get down to the details because the devil's is in the detail. They have all these fancy wordings, right? But as long as you know the contents, who cares what's being called? Who cares who's being called, right? But anyway, just to get back to Cortland's contribution, I really appreciate that. It was not a horizontal stretching. It's a vertical stretching. Horizontal stretching is something else. Okay, I will address that issue as we move along. Okay, as we move along. Today, I think we have enough contents. Okay, only this piece is a vertical stretching. Okay, this piece is vertical stretching. Okay, as according to the textbook. So when you multiply by a number larger than 2 to the output, or multiply the number by a number that, smaller than 2, we're talking about absolute value, and that will make the vertical stretching or horizontal stretching. But it's really hard to see this, to memorize this. Do you guys agree? I think that's the hardest thing to memorize. So how did I cope with it as a student with these kind of issues? I would just plot points to see for myself what it is. Okay, so the way I show it how it works, the detailed work we've done today is the kind of work I would have done if I were a student. In fact, I did it when I was a student. And that's how you get over it. When you get down to the details, it's not that hard anymore, isn't it? And in particular, the reward is that for a lot of the functions, as you see what we have done since the beginning of the semester, is that, we did a lot of hands-on. We did a lot of hands-on. I hope you guys have done it along with me. And everything becomes clearer and more, there's a certain consistency. But anyway, without further ado, I have passed the time. And I appreciate your attention to this matter. And please do, you're gonna have a quiz on this, okay? Today's lecture is gonna be in a quiz that's coming up your way, okay? I wish you guys have a great weekend, and I will be heading to my office hours, and have a nice day.
Thank you.
Thank you. Thank you everybody for your contribution, okay? Good job.